It's going to be lab number 8, push button auxiliary contact interlock. We're going to be looking at two different systems in this setup, so we're going to have two labs that we're going to be looking at. So let's go ahead and get started. First lab we're going to look at is the push button interlock and go through the operational characteristics of that setup. Okay, so what you see here is a de-energized circuit. We do have the power circuit up top, and a couple things we want to point out. A few of the things that we're going to look at is going to be our starter up here, which is a reversing starter. You can tell we have forward contacts up here, we have our overloads, our motor, our reversing contacts down here. And something we want to point out is that line 3 feeds through to T3, line 2 feeds through to T2, and line 1 feeds through to T1. However, when you look at going through the reverse, line 1 comes down here, feeds through the reverse, and then goes all the way back up to 3. 2 goes to 2, and then 3 feeds down and then feeds back up to 1. So we're following the NEMA standards for reversing on this, where we're swapping 1 and 3 to change the direction of the motor. Okay, now look down here, we have a forward contact or a forward push button with two sets of contacts. We have a normally closed and a normally open. Same thing on a reverse, we have a normally closed and a normally open. Now if you'll pay close attention, the forward normally closed feeds down and through and goes to the reverse normally open, and vice versa. The forward normally open feeds through and then goes up to the reverse normally closed. We're going to show you what that significance that has here in just a second. Alright, so when we push the forward button, and after we've got our disconnects closed, we pass power through our forward normally open by bridging the gap with our push button. It feeds up, goes through the reverse over to the forward coil, brings the forward coil on. That will bring this contact, this contact, and this contact on. It will also close this one and close this one, causing the motor to rotate. As you can see, we've brought on this contact, and these three. So we have a clockwise rotation on our motor. Our red light is on and our forward coil is energized. Now what this is setting us up for is our next operation. What we're going to look at is we're going to push this reverse button. Now, as is with every other circuit, when you have a going from a closed to an open or vice versa, you're always going to brake before you make, as it were. And what's going to happen is this reverse is going to open prior to making the closed on the normally open reverse push button. So it's going to stop the forward rotation before it will allow the reverse to pick up. Okay, now what's happened is when I got down into, or when the push button got into this no-go area where it's not connected anymore, the forward would drop out, causing these all to drop out, causing the red light to shut off. And as soon as I hit, because I'm feeding through this forward over here, now I have current that goes down and goes to my reverse coil, brings on my reverse contacts, main contacts, causes the motor to go into the opposite direction. As soon as I let the button back up, it remains in because this is closed, bringing on the green light and showing that I have reversed the motor's rotation, and now I'm feeding from 1 to 3, 2 to 2, and 3 to 1, which is NEMA standard for reversing the motor. We hit the stop button, and that cuts all power going to the circuit, shutting the circuit down. Next circuit we're going to be looking at is auxiliary contact interlock. In auxiliary contact interlock, what we're going to be looking at are the contacts here and here. Now if you notice, we have a normally closed on the reverse contact in series with the forward coil, and a normally closed forward contact in series with the reverse coil. Now, what this does for us is if forward is in the run position, then this one will be open, and no matter how much we push the reverse button, this coil will never energize, and vice versa. If we're already running in reverse, no matter how much we push the forward button, this coil here will never energize because this will be open. So let's take a look at how it operates. Okay, as you can see, we push the forward button, forward contacts close, we start motor rotation, we feed 1 to 1, 2 to 2, 3 to 3, and we have rotation. In this slide, you see that the forward button has come back up, but we have a sealant around it. Forward is still energized, our red light is on, and our F is closed over here, bringing that on. So everything that's dealing with the forward coil has been changed states, and it's allowing to be held on because of this reverse is normally closed. Now, we could push this reverse button all day long. It's not going to allow power to get over here because this forward right here that was normally closed is now open and not allowing power to get to it. Okay, you have to hit the stop button to get this circuit to shut off. You can't hit the forward button, you can't hit the reverse button again to shut it off. You have to kill power to it, and that would be through your stop button. Okay, now in this circuit, or this slide, what we've done is we went ahead and depressed the reverse button. You can see it comes through the stop button, comes down, goes through the reverse, brings on our reverse coil, brings on or closes a normally open, closes normally open, closes all three of these, but then it also opens up this normally closed right here. Does not allow any power to get to the forward coil. No matter how much you depress the forward button, it's not going to happen. So to shut it off, now after we let the reverse button come back up, to shut it off we'll have to hit the stop button. Once you hit the stop button, kills out the power to it, and we're back to our starting position basically. This is the end of the presentation for auxiliary contact and push button interlock. A few things of note: auxiliary contact interlock is going to be the most common interlocking system used in industry for the reasons of it's a little bit safer because you're making sure that when one of them's running, the other one does not allow power to pass through the opposite coil. With push button interlock, you have a couple limitations. It's designed for low torque loads and for 5 horsepower and under motors, so you're kind of limited as to the scenarios that you can use it with. Now, one thing about it is mechanical, push button, and auxiliary interlocked. All three can be used at the same time on the same circuit, just a matter of how you're going to wire them up.